So what I want to do is spend a little bit of time talking about Chapter 6A homework, and we're going to use Little's Law to evaluate each of the 4 problems here. In this first one, you are in a line at the bank drive-through and 4 cars are in front of you. You estimate that the clerk is taking about 5 minutes per car to serve. How long do you expect to wait? Well, a couple of things that we need to talk about is what is Little's Law and how do we use it? So Little's Law says that inventory is equal to throughput times flow time. And there are thousands of applications of Little's Law. And we use the symbols I is equal to inventory, R is equal to throughput because it's a rate that we're looking for here, and T is equal to flow time. And so the beauty of Little's Law is that you typically know 2 out of 3 of these things, and then it makes it easy to calculate the third. So let's look at a few examples of how we might be able to calculate that. All right. So in 6.5, again, you are in line at the bank drive-through and 4 cars are in front of you. Okay. So you estimate that the clerk is taking about 5 minutes per car. Okay. 5 minutes per car. That's a rate. Okay. To serve. How long do you expect to wait in line? So we're trying to calculate time. So that being said, I know that my inventory is going to be in terms of cars. My throughput is going to be cars per time, right? And my wait time is just a measure of time. And it says there are 4 cars in front of you. And then it says that you have 1 car every 5 minutes is the rate. So then to calculate my flow time, I use the formula that we have up here of inventory is equal, flow time is equal to inventory divided by throughput. So I'm going to take inventory and divide it by throughput, and that's going to tell me that it takes 20 minutes, right, for a car to get through that. Now, you could have maybe come up with just a quick calculation in your head, but I want you to start using these thoughts of this formula, because as things get a little bit more complicated, right, being able to identify what's inventory, what's throughput, and what's flow time is going to be helpful in terms of solving the more challenging problems. Okay, so let's go ahead and look at the next problem. So problem 2 is 6.7. So I'm just going to scroll down here and we'll do 6.7. And I'm going to want to know inventory, throughput, and flow time for this problem. The Avis Company is a car rental company and is located 3 miles from the Los Angeles airport. Avis is dispatching a bus from its offices to the airport every 3 minutes. The average traveling time for a round trip is 27 minutes. How many buses are traveling to and from the airport? Okay, so I need to know buses, which is my inventory value. So I know my throughput is bus per time, right? And it said that we have 1 every 3 minutes. Okay, I need to make sure that I have that as a number. So I'm going to go right click, format cells. We'll make these a number. And so it's 1 every 3 minutes. And then my time is in minutes. And it says that it takes for a total of 27 minutes. So my inventory is going to be equal to my throughput times my flow time. And that being said, there's 9 buses in the mix. Okay. And so then the next part of the problem says the branch manager wants to improve the service and suggests dispatching buses every 1 minute, right? Average traveling time is 4 minutes per bus. Okay. She argues that this will reduce the average traveling time to 4 minutes. Is she correct? Okay. So what are we changing here? Improve the service and suggest dispatching buses every minute. Okay. So instead of 1 bus every 3 minutes, in part 2, we're going to have 1 bus every 1 minute, and the round trip still takes 27 minutes. I'm going to format these cells as numbers again. So let me just, and again, this is 1 bus every 1 minute. And so basically that does not change the travel time at all, right? It stays the same. What changes is we're going to take our inventory, and it's going to be equal to our throughput times our flow time. And that is what actually changes, not the nothing about the time involved actually changes. Okay, and we can look at that by, coming down here. This reduces the average waiting time, but has no effect on the average travel time. The average travel time does not change and will remain 27 minutes. This would, however, result in 27 buses being in transit between the airport and the office at any given time. So we have to be conscientious about what components of time we're talking about, right? The total travel time of a bus is still going to remain 27 minutes, but a passenger would only have to wait 1 minute. Okay, so let's go ahead and go on to the next problem. So the next problem is 6.8. And it says, safety regulations require that the time between airplane takeoffs on the same runway will be at least 2 minutes. When taking off, the runway time of an airplane on the runway is 24 seconds. Planes are on average waiting 4 minutes and 30 seconds for takeoff. On average, there are 24 planes taking off per hour. How many planes are either on the runway or waiting to take off? Okay, so we're talking about planes per time, and time. Okay, so it's telling us we want to calculate how many actual planes. Planes on average are waiting 4 minutes and 30 seconds for takeoff. Okay, and on average, there are 24 planes taking off per hour. All right, so first thing is we have to make sure that we're using the same unit of measure. Okay, so I've got inventory, throughput, and flow time. So this is going to be 4.5 minutes per. So planes on average are taking off. Let me read this again. There are 24 planes taking off per hour. That's our throughput, right? It's planes per hour, right? And our flow time says that they are waiting on the runway for 24 seconds, right? And they're waiting, or they're on the runway for 24 seconds, and they're waiting 4 minutes and 30 seconds. Okay, so we want to convert that into minutes for us. And so what we're going to do is we're going to come back over here and we're going to go, okay, so we have 24 planes per hour, right? So right now we're planes per hour. Okay, and our time is given to us in minutes. Okay, and so what we know is that we have 24 seconds, right? And so 24 divided by 60 is that portion of a minute, right? But we're going to add to that 4.5. Okay, so that gives us 4.9 minutes. Our problem is we have to have both of these in the same unit of measure. So we're going to recalculate our time in terms of hours. And to get that, we're going to divide the minutes that we have and divide it by 60 minutes per hour. And that's going to tell us that we have 0.08167 of an hour. So to get to the number of planes, right, I know that it's equal to throughput in hours times time, also given in hours. Not sure what happened. I think, oh, this has to be a number. I have it formatted as text right now. And so that means that how many planes are either on the runway or waiting to take off? We're going to say 1.96 planes, right? So the key to this one is understanding where our throughput is coming from, that our time has to be a combination of both the amount of time that they're waiting and the time that they're taking off. And then that we need to make sure that we're in the same unit of measure. Okay, so that one has a few little spins to it. Let's go ahead and look at the next one. Okay, this one is a call center employee. A call center employs 1,480 agents. Every month, 40 employees leave the company and 40 new employees are hired. How long on average does an agent work for this call center? Okay, so we know that there are typically 1,480 agents. Here, I'll go ahead and make this view a little bit clearer. So we're going to do problem 6-10. And again, we're interested in inventory, throughput, and flow time. Okay, we have 1,480 agents in the process, and our rate of departure is going to be 40 employees per month. Okay, and so we're interested in how many months do they actually work at this call center. That's going to be equal to inventory divided by throughput. So they typically work at this call center for 37 months. Suppose the cost of hiring and training a new agent is $800. The manager of this call center believes that increasing agent salaries would keep them working for the company longer. The manager wants to increase the average time that an agent works for the call center to 48 months, right? Given the current average working time for agents at this call center, determine the current annual cost for hiring and training. Okay, well, this is going to be just a use of the information that says that we know that we have 40 agents leaving monthly. So annually, that will equal 40 times 12, which is 480 agents, right? And we know that those agents are 480 times $800, right, for training. And so that cost is going to be the $384,000. Okay, so that's how we get to this one. Then the next question says, assuming the average time that an agent works for the call center is increased to 48 months, determine the new annual cost for hiring and training. Okay. All right. So that means that our throughput is going to change, right? We knew here that our throughput was 40, but we're not exactly sure what it's going to change to. So I'm going to just do a quick shortcut and copy this down. But instead of this being what we know, we actually are saying that it's going to be 48 months. So then I'm going to say my throughput is going to be equal to my inventory divided by the months that an agent stays. And that's going to change to 30.83. Okay. Let me see if it tells me anything. Okay. And I know, again, that that's monthly. And so the cost that we saw above was $800 for training, right? So we're going to take this 30.83 times the 800 times 12 months to tell us that that cost should be $296,000, right? So again, just kind of a quick overview of the types of information that you can get from Little's Law is just pretty much infinite, and it's a very helpful law. In our process management class, we do a lot with Little's Law, and so I would look forward to those of you that have interest in better understanding processes and how this law applies in so many different ways. That LSC 452 is a great class to consider for that. All right, that gets us through 6A. So if you have any questions or concerns, you can send me your spreadsheet where you're trying to make these calculations, but I think this should put you in pretty good shape.